In this video, we're going to take a look at how we go about inserting a node at a particular location in a linked list. So it turns out the order in which we receive nodes to add into a linked list or to insert into a linked list may not be the order in which we want to maintain that linked list. So that's really what this video is about, is being able to find the location and logically look at how we update the pointers and what pointers we would need to keep track of in order to insert a node at any particular location in our linked list. So if you look at this example here, we have this linked list in which we have nodes that have names in them, and we're trying to maintain these nodes in alphabetical order. So we have April, Jim, Mike, and Sally, and we're interested in adding in this new node or inserting this new node, Ken, into our linked list. So you can see that we couldn't just use the add to head function because that would put Ken here at the very beginning. What we need to be able to do is traverse through our linked list and find the location, which is between Jim and Mike, to insert our node here that has the name Ken. So we're not going to be looking at a lot of code implementation. I'll do a full code implementation for insert function in the next video. But for this video, we mainly just want to focus in on the logical representation and how our pointer should be updated. And if you have a good understanding of the logical representation of what's going on, then it makes the code implementation that much easier. Really, linked list is really about drawing pictures. If you can draw the picture, you can usually write the code. There's three cases that we're going to have to deal with in terms of inserting a node into a linked list. One is inserting a node into an empty linked list, which isn't too bad. The second case is whenever we want to insert a node into a linked list that has at least one node. So we already have something there at the head of our linked list, but we're wanting to add our new node or insert our new node at the head. And then the third case is whenever we want to insert a node into a linked list and it already has at least one node, but maybe more nodes, but we're not interested in adding it into the head, but somewhere else in the linked list. So let's look at each of those three cases. So the first case that we'll look at is whenever we're inserting a node into an empty linked list. And this should be somewhat familiar to you if you watched one of my previous videos whenever we wrote that add to head function. So in add to head, we had to test to see if we're adding that node to the head of an empty linked list. So the way we test to see if we have an empty linked list is we just see if head happens to be pointing to null. It turns out whenever we first create a linked list, we should have that head pointer set to null. So we'd have some new node that we're trying to add in. So I'm going to draw a box here for our new node. And maybe we have a string here that represents some particular name. So maybe we have the name Bill here. And we have our next pointer. And we know that our next pointer is always initialized to null. And we would have some pointer here that actually points to this new node. And maybe we'll just call it our new node pointer. So we have that. So what has to go on? Well, once we find out that our head is pointing to null, the only thing that we need to do is set head to point to the new node. So we could do that. So let me go ahead and draw that picture. Let me erase this bit here. And we'll say that head is now going to point to our new node. And I don't want to do a complete code implementation in this video, but the assignment statement would be really easy, right? It's just taking our head node and we're just setting the address that's in our new node to our head node. So that's all anything that's going on there once we find out that we're dealing with an empty linked list. So let's look at the next case. So in the second case, what we're trying to do is insert the node at the head of the list. But before we can actually insert it at the head of the list, we have to find out that it actually belongs at the head of the list. So in the second case and both the third case, what we'll do before we get to either one of those cases is we'll actually do a traversal and find out where that node belongs. So in this case, the traversal doesn't go too far. We look here at the first node here, and the first node has this data member for the name Bill, and our new node has this name April, and we see that, hey, April actually should go before Bill, so this node should be going at the very head of our list. So what happens now is we need to take new nodes next, and new nodes next should be pointing to Bill, and head should be pointing to new node. So the way we make new nodes next point to Bill is first we just simply use the address that's held by head. Since head is pointing to Bill, we want new nodes next to point to Bill. So you'd have a bit of code like this. So you'd have new nodes next, and new nodes next should be set to head. So once we do that, we'll update this business here and have new nodes next now pointing to Bill. And then the next thing that we need to do is update our head pointer. So now that we've made use of our head pointer to get new nodes next at the appropriate node, or pointing to the correct node, we'll update head. So head is just going to simply point to whatever new node's pointing to. So we've done that, and we'll update the picture of that as well. So we'll erase this bit here, and now we'll have head pointing to a new node. So that's what goes on with the insertion at the head. And this should be familiar to you because it's the same basic thing that we did whenever we were dealing with add to head. Except now we have to have that traversal going on, which I haven't coded up here. We'll reserve that for the next video. That traversal to find out that we actually should be adding the node at the head of our list. So let's go and look at the third case now. So in the third case, we're in a situation where we've done a traversal and we found out that where we should be inserting that node is not at the head of our list. So we no longer have this head pointer to play off of or to make use of. So in this particular example, we have this new node that has Sally here, and we're interested in inserting it in this linked list here. So we can see as humans that, hey, Sally should be going between this Bob node and this Tom node, but we got to devise a computer algorithm to do that. So it starts off that we're going to be making use of a traversal pointer, and really we would have the same traversal pointer in case 2. I'm just going into more detail on this one, but it would be the same idea. So initially we would have a traversal pointer, and instead of calling it TP like what we did with the traversal video that I made, I'm going to call it something else. So I'm going to have this pointer here pointing to head initially, and I'm going to just call it current. Maybe I'll abbreviate cur, C-U-R-R for current. And it's just going to be pointing to the current node that we're examining to find out whether this new node that we're wanting to insert into our linked list should come after the current node. And we can see here that that's the case. So if we were to do a comparison, we see that Sally comes after April, and so we would update current. So current would now be pointing to the very next node. So let's have that. Current now points over here to Bob, and then we'd do another comparison. We'd say, okay, does Sally come after Bob? Yeah, S comes after B. And so then we would update current again. So now we'd have current being updated again. So we'll have current now pointing over here to Tom's node. And now we see that, hey, well, Tom comes after S, T comes after S, so Sally needs to go in between Bob and Tom. So we know that we should be setting new nodes next to whatever current's pointing to, so we can do that, and we can make new nodes next. So let me go ahead and erase this business here. We could set new nodes next, and change back to blue. So we have new nodes next, now pointing here, but we don't have a mechanism now to set Bob's next to point to this new node. We don't have a pointer here to make this next here point to the new node. So that's a problem. So what we're going to have to do is introduce another pointer. And we'll call this our trailing pointer, or our previous pointer. And it's going to simply point to the previous node, or the trailing node, the node that current was previously pointing at. So let me back up here and change our picture back to the very beginning. And now what we're going to do is we'll have to create this new node that we're going to call a trailing node. And I'll just call it our trail pointer, so maybe I'll abbreviate it trail. So we'll have trail here. And the trail pointer is going to be initialized to the value of null. So initially it's not going to point to anything. So we do the same thing that we did before. So we'd set here, we would look at what current's pointing to and decide, well, this new node has Sally, it needs to come after April, so we need to be updating current. But before we update current to point to current's next, we need to update trail here to point to what current's pointing to. If we don't do that, it could be the case that we had, say, Kathy here, starting with a C, and Kathy goes between April and Bob, and we would still need to have that trailing pointer. Of course, you could say, oh, well, you have this head pointer here, but it may not be the case that you're pointing at the head. So what we need to do is set our trailing pointer here. That's going to be the first thing that we have happen. Have the trailing pointer pointing to the same thing that current is pointing to. And then we can go about updating current. So current can now be updated so that it's pointing to the next node. So we'll have current now pointing here. And then we'd do the comparison once again, and we'd find out that this new node should be coming after what we're currently pointing at, Bob here. So what happens? Well, first we have to update that trailing pointer. So let me go ahead and update it. We're going to update it so that it's pointing to the same thing that current's pointing to now. So the trailing pointer is now going to, I'm going to slip it in here, and it's now pointing here to what current's pointing to, which is our Bob node, and then we can go about updating that current pointer. Very important we get those in the correct order, otherwise things do not work out so well. So then we had update here, so we're now our current pointer is now pointing to our Tom node. So now whenever we do our comparison, we can see that Sally here, this new node that has Sally, should in fact come before what we have current pointing to. And that's okay because we have our trail pointer pointing to the previous node. So what we need to do is update some pointers. We need to have new nodes next pointing to what current's pointing to. So let me go ahead and write that bit of code out. So we have new nodes next. New nodes next pointer is going to be pointing to what current's pointing to. So if we update that there, we'll go ahead and erase this bit here and update what new nodes next is pointing to. So new nodes next is now pointing to the same thing as current is pointing to. And now what we have to update is this previous node's next. Well, we have this trailing pointer here that points to it, so we can set trails next. So set trails next pointer, and trails next pointer should now be pointing to what new node is pointing to. So we'll have that. So we have those two lines of code that would be part of our implementation. So let me go ahead and update our pointer here for trail pointers next, so that it's now going to be pointing to our new node. So now we have a linked list where we've inserted Sally at the correct location. And it turns out that this bit of code would also work if we needed to insert this node at the very end, or at the tail of our linked list. And we'll look at the complete implementation. So I haven't written out all the code that you would need to have, but we've at least discussed logically what would need to happen and written out some of the important pieces of the code that you would have to have. And in the next video, we'll write out the full implementation that tests all three of these cases for inserting a node into a linked list. So that's it for this video.